Stanford University.
All right, well, welcome to Stanford CS193P. This is fall of 2017. I think this is lecture number 10. And we have two very important topics today. The first is multi-threading, and the second is auto-layout size classes. So let's talk about multi-threading first. Multi-threading is all about, for the purposes of this lecture anyway, keeping long-running things off of the main queue where the UI runs. And that's because we want the UI to be incredibly responsive. When someone touches down, we want to immediately respond to their touch and not be having our app freeze. It's just death to have your app freeze. Even for 1 second is an eternity for your app to just be not responding at all. So multi-threading is a much bigger topic. You can do a lot of other stuff with multi-threading, but we're going to focus on trying to get long-running things that might block off onto other threads. Now, the way that multi-threading works in iOS is using queues. Okay, so I'm using queue in the sense of like you go to the movies and you stand in line. That's a queue, right? And what's in the queues in iOS multi-threading is blocks of code. Almost always closures that you put in this queue. And so you got these queues. There's multiple different kinds of queues. And the system then comes along and it has threads. Okay, threads are threads of execution. They're essentially opportunities to run code. And it can run them kind of in parallel. Okay, I actually guess if you had a multiprocessor or multi-core processor, it could actually run things in parallel. But even if you had a single core, single thread of execution processor, the operating system knows how to share that time up in tiny little increments between all of these threads of execution. So the OS comes along and takes things off the queue. The next person in line, the next closure in line, takes it off and it runs it. Okay, so that's how we do queues. And there's two kinds of queues. We have serial queues, which is iOS comes along, takes something off the queue, and then as soon as that thing has run to completion, then it goes back and gets another one off that queue. That's called a serial queue. Then there's also concurrent queues, where iOS comes along and it grabs something off the queue and it starts it running, and maybe it has another thread that it can use and it goes and grabs another thing before the other one's even finished, and maybe another. And so it might have 2 or 3 or 4 or 10 things running off of the same queue all at the same time. Okay, that's called a concurrent queue. So we're going to talk about both of those kinds of queues because we're going to use both those kinds of queues to accomplish what we want. And what we want is for the UI to be unblocked, and the UI runs on a single serial queue called the MainQueue. And not only does the UI run on this, it's the only queue that can have blocks of code put on it that do UI things. So we keep all of our UI stuff here. That way we don't have to worry about multi-threaded UI where we got 2 different threads of execution both trying to draw into the same space or whatever. We never have to worry about that in iOS because all drawing, all UI activity happens on this one queue. Okay? And since it's a serial queue, it all happens on a single thread. Okay? So you never have to worry about multi-threaded UI activity going on. Now, the way the MainQueue works is it mostly sits there waiting for a touch event to happen. And when the touch event happens, it processes it, figures out what code to run, runs your code, and then goes back into this quiet state, waiting for another touch. Well, when it's in that quiet state, it could also pull something off the MainQueue and run it. Okay? So you can put things onto the MainQueue, blocks of code, and it will run in the UI thread, the main queue, the main thread. Okay? So our goal is to get everything else off the MainQueue. Anything else is going to take a long time, or certainly it's going to block waiting for the network or something like that. We definitely want that off the main queue. So where do we put those things? Well, we put those in global queues. Okay, now there's actually, you could create your own queue to do that, but we're going to use one of these 4 global queues. And these are concurrent queues that you can throw your code on, and the system will just come along and run them. And there's really no restriction there about what you can put in there. It's just it can't be UI code. Okay, but you can do other stuff all you want. So let's talk about those queues. How do you get the main queue? How do you get a hold of it? Well, there's a struct or class called dispatch queue, and it has a static var called main. That gives you the main queue. Okay, so now you have the main queue. You're ready to go, and I'm going to talk to you soon about how you put a block of code into the queue, right? Put it at the end of the line, waiting to run. The global queues are a little more expressive. There's not just one of them. There's 4 different kinds here that we're going to talk about. And the 4 of them are different based on their quality of service. That's what this QoS that you see referenced here. Okay, the quality of service tells you what kind of thing, what kind of activity the blocks that you're going to put on there are doing. So let's look at the 4. The first one is user interactive. This is a very rare one to use. This means that the user is in the middle of like dragging or pinching or something, and you want to do something off the main queue that has to happen so fast that it can get back to the main queue in the middle of that drag. Okay, so we're talking about highly interactive, tiny little pieces of work that you might want to throw off the main queue. The reason this is unusual to use is because if it's really so tiny and executes so quickly, you could probably do it on the main queue. Okay, you're probably waiting for it anyway on the main queue, so user interactive, much more rarely used. The most common one to use is the next one, user initiated. So now this is something that might take a very long time, or it might take a couple of seconds, and maybe it takes a few milliseconds, you don't know. But the point about it is the user has asked for it right now. They touched on a button, they swiped somewhere, and they're asking for something to happen. Okay, so it was initiated by the user. So they expect it to be done as soon as possible. Okay, so you are running this in the background, it's not happening in the main thread, but you're trying to do it as soon as possible. So this is a very high priority queue. Okay, the iOS is going to be pulling things off that queue and running them in threads that have very high priority because the users asked for it right now. The other two, background and utility. So background things are things the user hasn't asked for right away, but they're kind of things that they expect to be done fairly soon or when you have time, kind of a thing. And then utility ones are even lower priority. Those are things that your app wants to do as part of its architecture. For example, you have a big database and maybe every week or so or every certain amount of data in the database, you want to go clean it up, remove cruft out of the database. That's just a utility operation, so that will run at very low priority. Okay, so you pick the global queue you want based on the quality of service you want that queue to receive. All right? Okay, so you have a queue now, either the main queue or one of these background concurrent queues with a certain quality of service. How do you put a block of code onto that queue? Put it in line to get run at some point. Well, you do it with one of these two functions, async or sync. Each of them take one argument. That argument is a block, a closure. Takes no arguments, return no arguments. Or returns no values, okay? So it's just basic, as block as you can be. And what it does is it puts that block on the queue that you're sending it to. Now the difference between async and sync is that async puts it on the queue and returns immediately. And then just goes on to the next line of code you have. Okay, so now it's in the queue and someone eventually will go pull it off the queue and run it, but you return immediately. Sync, it puts it on the queue and blocks, waiting for someone to take it off a queue and run it and for it to complete. So you would never do sync on the main queue, right? Because we never want to block the main queue. But you might do sync on a non-main queue. In fact, you might do sync waiting for the main queue to finish something, okay, when you're on another queue. But mostly we're using async here because we don't really care. Async is short for asynchronous. We don't really care when it runs. We just want it to run whenever it can run. So that's it. So that's really all there is to multi-threading, believe it or not. It just leads to a little bit of interesting programming, which you're going to see here, and things you have to be careful with. Now, I'm not going to talk about this, but you can create your own queues by just calling dispatch queues initializer, which has this label argument, which is just, that label just shows up in the debugger, so you can see which queue you're on. The debugger is full support for queues. It'll show you what thread everything is on. And you can also do a lot of other things with multi-threading, like protecting critical sections in your code, or doing synchronous dispatch, or locking between things. You can do all that stuff. I'm not going to talk about any of that. Okay? I'm just going to talk about how we're going to use that main queue and those background queues to keep things off the main queue. There's a whole other API to this besides the dispatch queue API. I'm going to show you operation queue and operation are the two classes involved there. And those would be used if you're doing like some huge mathematical equation that has a lot of parallel processing that you could do, but a lot of the parallel pieces depend on each other because operation allows you to set up dependencies. Okay, this little block of code depends on this one running first, but I'm going to start these all off and just wait until the ones that depend get finished. You see what I'm saying? All these dependency management. I'm not going to talk about any of that either, but you get that by using the object-oriented operation queue and operation APIs. In this class, we're just going to use dispatch queue. Okay, dispatch queue is part of what we call grand central dispatch because we're dispatching these blocks of code onto these queues. All right, so where else are you going to encounter multi-threading? In addition to do your own multi-threading, like you'll see in the demo that I'm going to do today, you also might have iOS API that takes blocks as arguments, and when it runs those blocks, like when it finishes doing something or encounters an error, it runs those blocks off the main queue. And when you call that API in iOS, you've got to really be careful that in the blocks you give to iOS for it to run when it's done, don't have any UI in there, or if you do have UI, dispatch it back to the main queue, okay? Because you can only do UI stuff on the main queue. So let's see what it looks like to call an iOS API like this that takes a block. So here is an iOS API called URL session. This is used for fetching stuff from URLs over the network. We already saw in our demo on Monday how we did that with the data object, but that was kind of a dumb thing. You can't get any HTTP response out of it. The errors, you have to handle them kind of funny. This is much more sophisticated way to request something on the network, okay, URL session. It has a very simple API. You just create a URL session with a certain configuration. The great thing about URL sessions, you can do things like, I want my timeout to be 5 seconds, for example. Okay, you can't do that with the data thing. It's got some built-in timeout. Here, you can specify how long you want to wait before you time out on the network or whatever. So you create your session with some configuration, usually the default configuration. Now all you need to do to make it go fetch something is create a URL and call the function on the session called data task with URL. Okay, data task with URL creates what's called a data task, a task to go get some data. And it starts out paused, and then you're going to say the very next line, you almost always say resume, and that starts it going. Okay? Now, notice that that data task with URL function takes another argument. I'm using trailing closure notation to put it outside the parentheses, but it's just an argument to data task there. And that argument is a closure that this NSURL or this URL thing is going to call, URL session is going to call when it gets the data. And you can see the closure actually takes the data that it gets as an argument, which makes sense. Also response and error, which is HTTP response, and any error that might come along in there. Okay? So don't worry too much about that, but the bottom line is you give it a closure. Now the interesting thing about this closure is it's executed off the main queue. Okay? So if you want to do UI things in there, which you might well want to do because you want to do something with the data you got back, put it in the UI, can you do it in there? And the answer is no, you cannot, because you cannot do UI stuff off the main queue. Okay? But what if I need to do UI stuff? How do I do it? Well, you're just going to dispatch back to the main queue in there. Okay? Dispatch queue main, get the main queue, async, put the closure on that queue, and you do your UI stuff in there. Now, this all looks almost too good to be true. It's so easy, right? But there's a little bit to think about here in terms of timing. So I'm going to walk you through the timing of this code. This is the exact same code with just some labels on the lines here. And we're going to go through the step-by-step how this happens. First, line A executes, of course. We're starting to do this URL session request. Then line B, where we create this data task. This line B returns immediately. It immediately creates the data task and grabs that closure and holds on to it for a second and starts the task paused. So that's the second line that executes. Then line G, because of the fact line B returned immediately, of course, line G executes next, and you say resume. Okay? That starts that task fetching the URL over the network in the background, not in the main queue. So the next line that executes is line H. Okay? Because resume just instantly starts in the background, but line H continues in the foreground and runs. Okay? What do you think the next line that executes is? Well, about 5 seconds or 5 hours or 5 minutes or whatever later, line C will execute. This happens when the data comes back from the URL. Okay? So now I'm doing something with the data, processing it, looking at it, we're doing whatever I want. Then line D executes because I need to do some UI work, so I dispatch a closure that says do UI stuff here onto the main queue, and it gets in line to run on the main queue. But the main queue might be busy, or there might be other things on the main queue ahead of this closure. So this is not going to execute immediately. Instead, line F will execute immediately. So notice that line E has still not run. Okay, but line F has. Okay, what happens next? Finally, Line E runs whenever the main queue is quiet and ready to do it, and all the other closures that were ahead of it in line run, then E runs. Okay, so do you see what's happening with what runs when? So the code makes it look like the stuff will run top to bottom, but it doesn't. It runs a little out of order there because it's happening in a background thread. All right, so the summary is that it goes A, B, G, H, C, D, F, E. But this is only the most likely order because this is threads. Things are happening simultaneously. It is possible, believe it or not, that line E, the UI stuff, could actually run before line F. Okay, it's possible that it dispatches to the main queue and the main queue immediately grabs it. The main queue is a very high priority queue. Maybe it immediately grabs it and starts running it before F has a chance to even run. And if you have a single processor, that would definitely be possible. Okay, so that's the most important thing to understand about multithreading is its kind of asynchronous nature. And that will take some getting used to, believe me. All right, so the demo I'm going to do of multithreading is we're going to take Cassini and we're going to enhance its user interface a little bit. And then we are going to, where is Cassini? Do I have Cassini up here? Yeah, I do. Let's just hide that. Oops, no, let's just go like this. All right, so here's Cassini. So right now Cassini just displays this image, this demo URL that we made right here. So I'm going to comment that out, and instead I'm going to build some UI to use my image view controller as a generic image viewing MVC. I'm going to add another MVC, similar to like we did with the themes when we chose the themes. This MVC is going to pick which Cassini image I want to look at. I have some Cassini images, which I'll show you the URLs for in a second, that were taken related to the Cassini probe to Saturn, and I want to look at them on screen. So let's start by doing our UI first. So let's just go all UI here. So here's our UI, our existing kind of generic image viewing MVC. And I'm going to go down here and create a new view controller. Just drag it out here. Of course, view controllers all need to have their own subclass. So I will create a new subclass. I'm going to call this my Cassini view controller. Okay, I'm going to make sure I put it in the right place. Okay, not up to the project level. All right, so here it is. Okay, I'm going to select it and make sure I go to my identity inspector over here and change its identity to be image view controller. I'm going to have it be the place I enter. Let's go ahead and build our whole UI. In fact, let's make this work both on iPad and an iPhone. So I'm going to take this guy and I'm going to embed it in a navigation controller. I'm going to take this view controller right here, embed in navigation controller. And then I'm going to take this whole thing right here and make this be the master of a split view. And this is going to be my detail. So let's zoom way out here and grab a split view controller. Move this out. As usual, our split view controller brings out the document outline and has all this extra stuff here. Whoops, we don't need any of this extra stuff, so let's delete that. Then we'll zoom back in. Grab our split view controller here. Let's make the split view controller be where we enter, right? Let's make this be our master. Let's grab this and bring it down here and make it be our detail. Okay, so we've set this up. Hopefully you're used to doing this. You're doing this in your homework. It's pretty straightforward. So now we've got a UI that will pretty much work on both devices, both split view on iPad, and then also it'll work on an iPhone. So we need to prepare this image view controller right here, and we need to prepare this one, and we need some UI in this one to choose the Cassini image. So I'm going to do the same kind of silly thing I did before, but not quite as silly as it was last time, which is to put 3 buttons in here. So I have 3 Cassini images, so I'm going to have 3 buttons. Let's go ahead and make them big font here. 40 point seems to be my favorite size font. And the 3 images I have an image of Cassini itself, and then I have an image of Earth, and then I have an image of Saturn. Okay, because, oops, not Saturn. Saturn. Okay, because Cassini is a probe, went from Earth to Saturn. And I'll do a little review. We're going to embed this in the stack view. Okay, I'm going to make it fill. I'm going to make them be the same size buttons. I'm going to set the standard spacing here. Let's go ahead and put this in the middle. I'll go ahead and control drag to make this always be centered vertically and horizontally. You can see it's a little off center from there. So I'm going to go over to my document outline, which is where we resolve all auto layout issues with this button up here. I'll click on that. Here's all my problems. It's just this one problem. This thing's not positioned where it should be. I'm going to click the little triangle and fix it either by updating my frames or updating my constraints. In this case, my constraints are right, but the frame is wrong, so I will fix the misplacement. It moved it. No more auto layout issues. We have a great UI there. Okay, that's a quick review of auto layout. I'm going to try and review auto layout as much as I can because there's a lot to auto layout. All right, so now we're going to set up some segues from our master here to our detail. And I'm going to do this one a little differently before. Remember, before I had one kind of segue, one identifier, and then I looked back at the button title, and I said, that's kind of bad code because what if those button titles were in French? And then it's like, So I'm going to do this a little bit different way. The real way I would do this probably is I'd use a table view, okay, which is this extensible table list of things. And then I could both add more things, and also it could easily find out which one was picked by its index into the row of tables. But I haven't taught you table view yet, so that's why we're using these button solutions. All right, so I'm going to create a segue from Cassini down to here. It's going to show detail because we're in a split view. Same thing with Earth, show detail, and with Saturn, show detail. But instead of having them all have the same identifier, I'm going to give them each a different identifier, which is which image to open. That way, if I change the language here, they'll all still open the proper image. So here, this one is the Cassini one, right? So I'm going to have its identifier just be Cassini. And then this one is the Earth one, so we'll have its identifier be Earth. And this one is Saturn, so we'll have this be Saturn. Okay, so I'm just setting the identifier of these segues so I know which one to show. A little bit better, more kind of accurate way to do that. But now, of course, we need to prepare our generic image view controller, set its model, its public model, which is that image URL. So let's go look at our Cassini view controller code right here. We'll clean out all the junk. All right, these are view controller lifecycle methods. Hopefully you recognize. We'll get rid of those. Let's uncomment out our navigation stuff here and do our prepare for segue. So how am I going to prepare for the segue? Well, I need to look at the identifier to see which image I'm going to show. So let's say if we can let identifier equal the segue's identifier. In other words, it's not nil. Then I'm just going to see if I can get a URL. Here's my demo URLs. I showed you this before, but let's show it again. See, I have this dictionary here, this NASA dictionary, that has strings as the keys and URLs as the values. And so for each one, Cassini, I have a little URL. For Earth, I have a URL. For Saturn, I have a URL. So I'm just going to look up in this dictionary to see if I can find the name of the identifier. And if I can, then I know I have an image to show. So let's do that. I'm just going to say, oops, not identifier, fire. Okay. So here I'm going to say if I can let the URL equal my demo URLs dot NASA sub the identifier. Okay. So if that comes back true, I was able to get an image, and so now I can do a segue to an image showing view controller, which is my image view controller I built in the last lecture. So I'm going to say if I can let the image view controller equal the segue's destination as an image view controller, then I can set the image view controller's public API. Let's remind ourselves what that is. Here's the image view controller that we worked on last time. Its public API was this. Image URL sets the URL you want. So we're going to set that public API image URL equal to the URL. I'm also going to set the title of this thing. And here I am going to use the button title. Sender as UI button. If it's in fact a button, get its current title. Now, is this bad? This one's not so bad. Because here I'm setting the title of that destination image view controller to be the same as the title of the button. Well, presumably the button is localized to the local language, so I'm putting a button title now in the title. It's not so bad. It's not a bad, this one's not bad because we're talking about UI elements that have been localized in both cases right there. Okay, so that's really all we need to do to prepare. Let's go ahead and run and see if this works. We'll run this on the iPhone here. And hopefully when we click on one of those buttons, it will go out and hopefully the network will work today and it will fetch those images. Now those images are quite large, so it might take a while to do. Right. So here we go. It comes up showing the detail, right? We didn't put the little split view trick in there to make it collapse the thing. So let's go back here. Here we go. Here's our UI, Cassini, Earth, and Saturn. Let's try Cassini. Oh, it didn't work. Okay, so why did this not work? Let's go. Oh, sorry, I did something in the storyboard. Let's go back and look. I love it when the students are on top of it. So what did I do here? Oh, this one right here? Oh, yeah. Huh, that's interesting, yeah. Okay, so when I set the identity of this right here, I accidentally set it to image view controller. It should be a Cassini view controller. Where is my Cassini view controller? There it is. Good catch right there. I probably could have looked at that for 5 minutes. All right, so yeah, so I accidentally, after I made it, I picked the wrong one. So here we go. So that's a common thing to do, actually, to either forget to set this guy's identity or to set him something wrong. So why did that make this not work? Well, because this prepare right here was not getting called because that was not a Cassini view controller, but now it is. So let's try it again. Okay, so here we go. Go back. Let's try it. Cassini. Hopefully it doesn't seem to be working. Oh no! It crashed. Okay, now it crashes. We hate crashes, but hopefully we're getting comfortable with looking at why crashes happen, especially looking here at our backtrace. So let's look and see what happened here. Why did this crash? Well, we're crashing in our image view controller, right? There's our image view controller where we set the image. Okay, this is where we set the image to something, we size to fit, and then we adjust the content area of our scroll view, right? But, oh no, something's nil here. Well, we know the image view can't be nil because we set it right off the bat to be an image view. So it must be that this scroll view is nil. Let's see. Self, here's my self down here. Oh yeah, sure enough, self scroll view is nil. Huh, well let's go back up the trace here and see what's happening. Okay, this is happening because someone set our public API. That makes sense. And we're setting the image to nil to clear out any old image. And where was that called from? Oh, prepare for segue. Oh yeah. Okay, anytime you have a crash, something's nil, and you were in your prepare for segue, you're going to go, oops, I have an outlet, and it was not set. Because that's what happens, right? Prepare happens before your outlets are set. And so when we look up here, this is an outlet. Scroll view is an outlet right here. And it's not yet been set because we're preparing. So what's a good fix for this? How about we just optional chain? Okay? That makes it so that this line will be ignored if scroll view is nil. And that's okay because all that's happening here is that we're trying to set the image to nil anyway. But since we're just preparing, it's going to start out nil, so it won't hurt anything to do that. Okay, so here's where we want to do that. Okay, it's a simple fix to it. So I obviously left that in there again so we could do this again because I know you guys run into this crash and you want to make sure you're comfortable with diagnosing it. So let's go back. Let's try again now. Cassini. Oh, it doesn't seem like it worked. Oh, wait, it did work. So what happened there? Okay, so let's see. Is this my Cassini image? Oh, yeah, look at that. There's the Cassini probe right there. So let's try another one. Let's go try Earth. Oh, no, it didn't work. Well, let's go to landscape. Oh, how come it's not going to landscape here? Forget it. Let's go back. Oh, the back button. It doesn't work. What's going on here? Okay, so you see how my UI was stuck there? I was trying to do back. I was trying to rotate. My UI was just blank, not doing anything. See, my UI is completely and utterly stuck. No matter where I touch, even if I rotate, nothing happened. Well, this is a horrendous experience for your user. Okay, this is the kind of experience that will cause your user to go and delete app. Okay, because you cannot have your UI freezing up like that. So that's why we have multi-threaded. That's such an important piece of the kind of app development we do in iOS. So let's go in here and see if we can fix this with multi-threading. So how are we going to do that? We're going to go back to my image view controller. This is the thing that's hanging. In fact, it's this line of code right here that is hanging my app. Right? This is where I'm trying to go out on the internet, get that Cassini or Earth URL, and it's big. And even on our fast Stanford network. It's taking a long time to come over. So this line of code is not returning. So I cannot have this line of code executing on the main queue, which is where all my code pretty much runs unless I specifically put it somewhere else or unless I use some iOS API that puts it somewhere else. All right, so how do I get this off the main queue? Well, I just use this dispatch queue, main queue, and then use the async func to put a closure onto the queue. So this is going to take this code and run it on a different queue. Now, I don't want to run this on the main queue, though. I want to run it on one of those quality of service queues. So how do I do that? I'm going to call global queue, and the argument I want to it is quality of service, not QoS, quality of service, and the one I want is user initiated, because the user did just ask me to do something, right? So I'm going to put it on the queue that gives me that good quality of service that I want from something initiated. And what am I going to do here? Well, I'm just going to do this right here. I'm just going to put this right there and go do that. And this will immediately stop my app from blocking like that because it's going to be doing this network fetch on some other queue. Now see, it's complaining here because, of course, this is now inside of a closure. Okay, so I have to do self like that. Now, every time I do this, what did I tell you to do? Check to see if you have a memory cycle, right? And we don't have one here because self does not have a pointer to this closure. Okay, there's no pointer inside self that points to this closure, so there's no cycle. However, with multi-threading, when you do this self dot, you have to think of another thing, okay? Which is, what happens if the code before this line that has the self takes a long time to execute? So long that this ViewController doesn't even want to be here anymore. Can't you imagine that easily happening? Someone clicks to go get an image. The image is taking 5 minutes to come along. They're like, forget it. And they click somewhere else. Okay? Go back or something. Now that ViewController that requested that image, it's meaningless. It has no value. It should not be in the heap. But it's being kept in the heap by this closure. Do you see? Because I have a reference to self in this closure, this ViewController, my image ViewController, is being kept in the heap for as long as that image request is outstanding. So this is a case where I want to do weak self here. Okay? Not having anything to do with memory cycles, but having to do with the fact that I don't want self held in the heap by this closure. If this closure takes so long to run that the user doesn't care about self anymore, then I don't care about self anymore. So by definition, I want it to be weak. Everyone, any questions about that? So that's another thing you need to do when you type that self dot, because Swift warned you about this inside a closure. If you're doing multi-threaded, think about whether things want to be weak here or whether you really want to hold things in the heap. Okay? All right, so this is good, but this is not going to work either. While this will stop my UI from blocking, it'll probably screw up my UI. Probably cause my UI to draw all funny or get completely wedged. And why is that? Because this line of code. Okay? Here I'm setting image, which is this thing right here. And if you look at the setting of image, it sets a UI image views image, that's a UI thing. It's sized to fit that UI image view thing, that's a UI thing. It sets a scroll views content area to a certain size, that's a UI thing. I'm doing all kinds of UI stuff when I set this image. So I can't do this on the queue that I put this code on. Okay, this global queue is not a UI queue. I can't do it there. So what I have to do here is to dispatch queue main async this code back to the main queue. Okay? Now, it's going to get in line and run on the main queue when the main queue is quiet. See that? So this is cool. This really, like you can see, this code is awesome. This is like the easiest multi-threaded code you can possibly write. But you do understand that this stuff is happening perhaps a minute after this line of code, right? Okay, because we're putting on another queue. It might be blocking on the network. Now, that leads us to one last thing we need to do here, which is what happens if we request this thing, and not through our UI, but in some UI, someone calls this image URL and sets it to something else. Okay? They set this image URL to something else, and we go to fetch that image. What happens when this image comes back? We don't care about it. we're off on working on a new image. So when this comes back, we need to check to make sure that our current image URL is the URL we requested here. And we can easily do that by just saying URL equals our image URL. Okay? This is weak, so we go like that. So here I'm just checking, after this maybe takes 5 minutes, I'm checking to see if that URL is the one I asked for. Because if it's not, I don't care about it anymore in this class. Do you see? So this is what I'm talking about, where when you're doing multi-threading, you have to think about the timing of things. Things might take a while. When they come back, things might be different than they were when you left. Okay, so this is a great little piece of code to really understand because it covers a lot of ground, from the weak self and checking this and dispatching back to the main queue, getting one of these background queues. Okay, really make sure you understand this little piece of code right here. All right, so let's run and see if this has indeed fixed our nice UI to be responsive. Okay, here we go. Let's try it again. Let's go Earth, and can we go back? Woohoo! Look at that. I can go back and say, no, I want Cassini. Here comes Cassini, and Earth is still probably being requested, and here comes Earth, and it didn't do anything. That's great. It just dropped it on the ground because we don't care about Earth anymore. I changed my mind. So here's Cassini. That's great, right? I can rotate. We can go back. Let's pick Earth. Now, while I'm waiting for Earth, I could rotate. My UI is completely responsive. I could go back and choose something else. Let's go ahead and let Earth arrive. Earth is a big image. There it is. Okay, Earth seems to be a picture of people somehow. Maybe we'll zoom out a little bit. Oh, it's the Earth. Okay, so this is a picture of Earth made up of a lot of little people looking up and saying hello to Cassini, and that's what this one is. And similarly, they have a similar kind of construction with Saturn here. But you can see that our UI is just dramatically improved by putting that stuff on the other thread there. Right? Okay, but our UI is still not that great because watch. What's happening right now? The user has no idea. They wanted the Earth image and it's not here. And they're like, well, I guess there's no Earth image, you know. And they click back. We need to give them some feedback that we are off getting their Earth thing. Okay, we need something to let them know, yeah, I'm working on it. Okay, even though you could hit back, you could stay here and you could see your Earth image. So how are we going to do that? We're going to do that with a little spinner, okay, called an activity indicator. It's just a little spinning view. And this is a good one to show you for another reason too, which is that it can sometimes get a little crowded trying to build the UI you want, especially when things go all the way to the edges like this scroll view. So this spinner, you can search for it, activity, it's called UI activity indicator view. See it right here? I'm going to drag this out and try to put it in the center of my image view right here. Now, this did a very bad thing. Okay, you can't tell, it looks like it's just fine, but it's bad. But the way you can find out and see the badness is going to your document outline. If we go to the document outline and try to find this indicator right here, you see it? Look what happened to it. It was made a subview of the scroll view. Okay, anytime you drag a view in, it gets made a subview of the thing you drop it on. And we don't want that, because we don't want this scrolling thing to be in the content area of the scroll view. That's what a subview of scroll view means in Interface Builder, the content area. We want it to kind of sit on top. And luckily, it's super easy to pull it out on top in the document outline. It's very difficult to pull it out on top over here. But here we can just lift it up and put it, actually that puts it behind, and here we can put it in front. So now it is not a sub view of the scroll view. It is in front of it, sitting in front of it. Now, we also want it to be centered, but not centered in the scroll view. We want it to be centered in the super view of the whole, you know, the whole MVC. So how can we do that? I mean, my gosh, it's going to be impossible. Control drag, how do I find the edge without hitting the scroll view? It constantly wants the scroll view right there. Well, we can control drag in here. Look at that. Okay, control drag up to here and say we want it to be centered horizontally and vertically in the safe area. Okay, we got a little misplacement there, no problem. We'll fix that. Update frames. Boom, it put it in the middle. Okay, so control dragging inside the document outline is a very good way to get at things that are hard to see. Now, another thing we want to do is, this is a very tiny little controller. I want a bigger one. Turns out there is a bigger one, this large white one. Although I don't want it white, because it's going to be white on white. So I'm going to pick a different color. Let's make it blue, let's say. Okay, so I got this nice spinner right here. This spinner, by the way, you can either start it out animating or turn it on when you want, which is what we're going to do. Also, you can have the spinner automatically hide itself when it's not spinning. Okay, and then when it is spinning, it shows itself. So we want that too. So let's go turn this thing on and off. Let's go turn this spinner on and off. Where do we want to turn? Well, first of all, we need an outlet to it, of course, if we're going to talk to it. So let's put that outlet right here. I'm just going to control drag, normal outlet. I'll call it my spinner. That's what I like to call my activity indicator there. So here it is. And we just need to turn this thing on and turn it off. Well, the place we need to turn it on is right before we do this really long, expensive operation. So I'm going to say here, spinner, start animating. That's how you turn it on. And where do I want to turn it off? Well, you might think I want to turn it off in here, okay? But again, thinking about multi-threaded, really I don't want to do that because what if another image request goes out and I'm waiting on it? I still want the spinner to keep spinning. Really, I want the spinner to stop spinning whenever the image actually gets set. So anytime we actually set our image to something inside here, then I want to stop my animating. So I'm just going to say spinner, and I'm also going to be careful here of people preparing getting me. Stop animating. Okay? So this is a reliable place to stop animating. Once I put an image there, I clearly don't want that thing spinning anymore. Okay, so let's see what that looks like. Okay, so we didn't request anything, so there's no spinner. Let's go here, ask for Cassini. It's spinning, you see, and as soon as Cassini arrives, it stops spinning. If we zoom down, you'll see that it is not there. It's hard to see in this background, but it's not there. Okay, and let's just quickly make sure this is all working on an iPad. Let's go up here, iPad, and run it on there. It's kind of especially acute on iPad. When you click this, if you don't have a spinner there, it's really unclear what the heck is going on here. Okay, right, Earth. And while this is spinning, we could change our mind and go to Cassini. Okay, and now it starts, now there's a new ViewController, and it starts again, and now we get Cassini. Now, one thing that's kind of a bummer here is when we were on the iPhone, remember we took the title of the button and we put it on the top, and there was a title. But notice on the iPad, there's no title here where the detail is. Okay, the detail has no title on the top. It's just kind of up to the upper left-hand corner. It's kind of ugly, actually. So I'd really love to put a title over here, just like I have a title right here. So how can I do that? Well, it actually turns out to be quite easy to do that. I'm just going to take my detail right here, and I'm going to embed it in a navigation controller. So I'm putting this in a navigation controller not because I'm doing any navigation down there. The navigation I'm doing is all controlled by this one, but just because I want the thing to have a title. Okay? Now, let's see, does that work? Okay, let's run and just see if that works. All right, here we go. Cassini. Uh-oh. Oh, no. It's not working. I'm not even getting my spinner anymore. That broke it. It put a title up here, but it broke it. Now, why did that break our code? Well, let's look at our code, and we'll see pretty obviously why it broke it. In our prepare for segue, what do? We look at the segue's destination, which is the detail, and we check to see if it's an image view controller. But it's not an image view controller now, is it? Right? If we go back to our storyboard, the destination of these segues is a navigation controller. Not an image controller, it's a navigation controller. So that line of code is failing, right? This line of code is image VC equals their destination is image view controller, not true anymore because our destination is a navigation controller. So we can check that though. Let's just go set our destination here equal to the segue's destination. I'm going to say if I can let navcon equal destination as a UI navigation controller, then I'm going to let my destination equal that navcon's visible view controller, which might be nil, in which case then I'll go ahead and return the navcon. Okay? And then here I'm going to use destination. And so this is going to basically unwrap the navigation controller and get its visible view controller. This would still work if there weren't a navigation controller there, because then this line of code would not happen, and we'd just be saying segue destination here. So let's see if that works. Okay, here we go. Cassini. Look, oh, we got the title, we got the spinner. Whoo, it's working. Okay, Earth, put the title, spinning. All right, now, this is very common to want to do, to put your detail in a navigation controller, and you have to do this little indirection. A lot of times what I'll do is create a little extension to UI view controller. Okay, it's a little var I call contents, which is the contents of the UI view controller, which for most view controllers is just itself. But if it's a navcon, if we have to do this little doohickey here, then it'll return its visible view controller. So I'm going to say, if I can let myself be a navigation controller, then I'm going to return my visible view controller. Or if that's nil, then okay, I'll return myself. And if I'm not a navcon, then I'll just return myself. So contents just is the view controller itself, or if it's a navigation controller, it's the contents of the navigation controller. You could also do this with tab bar controller. You could have an else if it's a tab bar controller, then show me the view controller that is the current tab. You can do the same thing. So here I don't need to do this anymore. I can just say segue.destination.contents. All right, and this is going to give me what I want. See how this cleans up this code really nicely? So you'll often want to have an extension like this when you have your detail might be wrapped in a navigation controller. Okay, Cassini works perfectly there. All right. Yes?
Can we go to the where you compare the URL to URL that comes back with like self-URL?
Yeah. Right here.
So where does the URL that isn't the self-URL come from? So then you like set it, you say if let URL equals image URL.
Yeah.
But how does that get defined when you're inside the base?
Okay, so by letting URL equal image URL, we're creating a local variable called URL. It's a local variable local to this function, and its value is the image URL. Okay, now this closure right here, and this closure for that matter, closures always capture the local variables around them when they need them. And since we're referencing URL inside these closures, it got captured. So it holds on to this. Even for 5 minutes or however long this takes, it holds it in the heap. As long as this closure lives, okay, it holds on to it. But it still stays set to what it was before. If in the meantime, while 5 minutes is happening, this changes, that doesn't change this, because this is a local copy, right? It's a local variable that's a copy of this thing.
But how does that have a value just because you say, isn't it like a new instance of an image URL? How does it have an actual value?
Well, okay, so image URL, I don't know whether URL is a value type or a reference type. It wouldn't matter here, okay? But let's say it's a value type. If it's a value type, then we know this copied it, okay? And then when we say equals equals, it means the two that URL would have to implement equatable, which certainly it does, okay? If this is a reference type, then it's just grabbing a pointer to that thing. And then here, we're comparing the pointers. So either way, it's going to make sure that if it's changed, we know. Okay? Good question, though. All right, let's get back to our slides here. Okay, let's talk about our other very important topic today, which is more about auto layouts. I'm going to do a quick review of auto layout just to make sure you understand what you understand. Here's kind of some of the things we've seen with auto layout so far. We know to use the dashed blue lines to try to tell Xcode what we mean, right? Putting things in the center, putting things on the edges by the dashed blue lines. And then we can do reset to suggested constraints, remember, in the lower right corner, which will try to make constraints that make the blue lines make sense. But we know it doesn't really work more than about 50% of the time. So then we learned how to control drag to the edges or to other views, and then set the widths or aspect ratio or the edges to be the same or whatever. We know that we can go to the size inspector and look at all the constraints that are constraining a certain view just by clicking on the view. looking in the size inspector. And we can even edit simple things about the constraints right there in the size inspector, like constant values or things like that. We also know that if we can get at it in the interface, or we can click on a constraint and open up the inspector and inspect detailed information about the constraint. Okay? We also know about the pin menu in the lower right that lets us set some constraints, like hooking it to the edges and things like that. There's also an arrange button down there, by the way. I didn't show you, but it's similar. Lets you line up front edges and things like that. And we also learned that the document outline is the awesome place to go to really look at our constraints in detail, because it lists every constraint as a line item. It's also where the special place do you click to resolve problems with your constraints is. So the document outline is just fundamental to using auto layout. So we know all that stuff. Understand that mastering auto layout takes experience. Okay, you don't just have someone tell you all these things or even show them to you and it's like, oh, now I can do auto layout now. You have to have laid out a lot of things and understood the conflicts that arise and what the limitations are and all that. It's really a fantastic system, auto layout, very powerful, but it does take some experience to master. So don't get too frustrated. Luckily, you're going to have more assignments where you're going to have to do auto layout, and your final project, you're definitely going to do auto layout, so you will get some of that experience. It is possible to do all this auto layout stuff from code. In other words, not with control dragging and all that, not in Interface Builder, but actually write code to do all of this. And I'm not going to teach any of that, unfortunately. If you want to learn a little bit about that, you can start by going to UI Views documentation and search for Anchor and auto layout. Those are the two main sets of API. There's a ton of API there. And then there's also just documentation, how to do the auto layout system. You can read through all that if you really want to get to be a master of auto layout from code. Okay? It's not necessarily that difficult, but it really truly requires understanding auto layout and how it's working to do it from code. All right, having said all that, auto layout is sometimes just not enough. Okay, the auto layout you know so far is just not enough. Okay, sometimes when you rotate your device, your geometry changes so dramatically that there's just no way to control drag to make things happen. For example, in concentration, we know that concentration with a lot of buttons looks great in portrait. All the buttons kind of look square, but then when you go to landscape, the buttons are all smashed down. There's barely enough room to say flips 27 at the bottom. And it just really gets smashed. It really would be great if when I switched to landscape, if I had 20 buttons, let's say, it went 5 across and 4 down. Maybe even move that flips thing off to the side. That would be much better in landscape. But no amount of control dragging to the edges is going to make that happen, right? It just can't be done. It's just, you cannot constrain the views enough to make them relay themselves out like that on rotation. So what's the solution to that? Size classes. Now, Apple made, I think, a great decision that when you rotate to landscape versus portrait, instead of their reporting to you, here's your new dimensions, figure it out, they just simplified it down to 2 and only 2 values for your horizontal and vertical size. Okay? You are either compact or regular size in width and height. And that's it. They're going to report that to you, and there's a whole system for letting you know when that changes. And then you build your UI so that it looks good when it's compact vertically, it looks good when it's compact horizontally, it looks good when it's regular vertical, and it looks good when it's regular vertical and horizontal, right? So that simplifies the system dramatically, and you're going to see that it works in the vast majority of situations. So let's talk about this whole size class thing and how it works. First of all, you have to understand what the devices, what size classes the devices are in. For example, iPhones are compact in width and regular in height when they're in portrait. Okay? When you rotate an iPhone, not an iPhone Plus, but a regular iPhone, when you rotate it, now it is considered compact in both directions, which is a little counterintuitive. You would think, oh, well, now it's regular in width. But no, it's considered compact in width. And it's amazing how often that turns out to be exactly what you want. All right, and you'll see that to be the case. Now, iPhone Pluses are different. iPhone Pluses are still compact in width and regular in height in portrait, but when you turn them to landscape, now they are regular in width and compact in height. Okay, so iPhone Pluses are different than regular iPhones in that way. iPads are regular width and regular height. Portrait or landscape, doesn't matter, they're always regular in both, which you can imagine, they're big, iPads are huge. However, notice that an MVC that is in the master of a split view is compact in width. Even though it's on an iPad, it's still compact in width, regular in height. Okay? So it's not just the device you're on that says what environment your MVC is in. It might be the MVC situation that it's in. Okay? So that's why we don't look at things like, am I on an iPad? Because then I'd have to say, am I on an iPad and am I in a split view? Okay? We just ask, am I compact or am I regular in my width and height? And then we react to that. Okay? So here are all the devices in a little grid for that. And let me show you what an app, so here's an app like a calculator, similar to our concentration. Calculator has a lot of buttons, and maybe it'll look better with 5 across and 4 down in the 2 cases where it's compact height. See, whether it's compact width or regular width, it still looks better to have only 4 high in a compact height. And when it's regular height, it always looks better to have 5 high. Maybe even more would be better, but it always looks better to have 5 than 4. So this is what we're going to do in the demo. We're going to do concentration, same kind of way as this calculator. Okay? Now, we know the size class we're in. We always know that as our MVC is doing its business. Okay? What can we do based on that knowledge? Well, one thing we can do is vary a lot of view properties, like the fonts on a UI label, for example, the background color even, whether a view is hidden or not, even whether a view is even in the view hierarchy can be controlled by a size class. So if you're compact height, maybe you have a view that's just completely hidden in compact height. Maybe it only appears in regular height. That's perfectly controllable using your size class. But more importantly, and the most powerful thing you can do, is have your constraints be tied to your size class. Okay? Because remember, what puts anything on screen in any place? Well, it's just the constraints, right? The constraints are what constrains a view to being in a certain space in auto layout. Well, if you can control those constraints using the size class, then you can make those views move around to different spots depending on your size class. Like go 5 by 4 instead of going 4 by 5. Or moving the little flip label off to the side. Okay, so constraints, being able to control constraints with your size class is really the power of this size class stuff. Now the cool thing, by the way, is Interface Builder has support for doing all of this graphically. So you don't even have to do this in your code. You can do it all graphically. Now it is possible to find out what your size class is in code. For example, if you want to know your horizontal size class, whether you're compact or regular horizontally, you just call this method. You access this object that's in your ViewController called trait collection. It's the collection of all your traits, and one of your traits is your horizontal size class. You can get it back. It's an enum. It's either compact or regular. Okay, I suppose it could be unspecified, but that wouldn't actually be that while you're running. Okay, again, it's rare to do this. We're going to do this all in Interface Builder, and so that's something that's all visual, and so I'm going to have to show it to you in a demo. This is one place where a demo is worth 1 billion words, okay? To try and explain it without the demo would be almost impossible. And so I'm not going to get back to the slides, so let me just summarize here that we do have a Friday section. Please come to it. On Friday, it's about instruments, which is a performance analysis tool, and especially when you're doing the multi-threaded stuff, you want to know what's taking a long time to execute. Right? So that you can put it off in another thread. Sometimes it's obvious when it's a network blocking thing, but other times you have stuff that you're computing that actually turns out to be taking a lot of time. So using instruments to find out what that is will save you a lot of putting stuff on other threads that doesn't need to be, okay? Only the stuff that needs to be. You all know Donald Knuth, right? Don't prematurely optimize. Don't obfuscate your code to make it run faster unless you're sure that's actually what's running slow. Well, you need instruments to know that. Okay, next week we'll dive into some more topics, table view, collection view, drag and drop, stuff like that. Okay? All right, so let's go and do our concentration. So here is concentration. It's exactly where we left off except for 2 changes. One change I made is I turned off all the ViewController lifecycle logging, because if we need the console, I want it to be clear so you can see things. I don't think we'll need the console, but yeah, you never know. And then I added more buttons. This used to have 12, so I just added a couple more rows of buttons here, so there's 20. So let's see what it looks like now with those 2 very minor changes. I haven't changed any of the code or anything like that. All right, so here we go. So let's do sports. Oop, working like a charm. Okay, looks good. And of course, in, uh-oh, that's not so good. Okay, I added those more buttons, but it caused the flip count, you know, the flip count that's at the bottom here, flips 8, whoop, it got pushed completely off, okay, because, and look at the buttons, they're barely big enough to hold the emoji anymore. Also, they're ugly buttons, they're really flat, okay, a lot of blank space on the sides. Ugh, this UI looks terrible, okay. So we're gonna fix this UI by doing two things. One, we're gonna do 5 across and 4 down, only in landscape, because back here, we like these nice square buttons here, and we wouldn't want to switch to 5 across and 4 here, and then it would start looking bad here. Okay, so that's one thing we're going to do. And the other thing is we're going to move this flips thing, okay, in landscape to be over to the side here, over on the side. This will help the buttons be even more square and use the space more efficiently on the side. Okay, so those are the two things we're going to do. All right, so how do we do this? How are we going to do this? Well, we need a strategy for doing all this. And my strategy is going, and remember, we haven't looked at this a lot, but remember you can look at all your devices down here, including whether they're in landscape or portrait. So here I'm looking at this thing in landscape. And here's where my problem is. It's 4 across and 5 down. I want it to be 5 across and 4 down. So my strategy is going to be, I'm actually going to add 4 buttons here. And then when I'm in landscape, I'm going to hide these 4 buttons. And when I'm back in portrait, I'll hide the new buttons I added. So I'm actually going to have 24 buttons, but 4 of them will be hidden in one or the other. See that strategy? So this is one strategy for doing it. It's a simple strategy, so we're going to start with a simple strategy. All right, so let's do that. Now, to do that, so you can see what I'm doing a little more, I'm actually going to see this little constraint right here. This is the constraint that's holding this to this right edge. I'm going to delete this constraint just temporarily here, so it makes some space for me to work. So I'm just going to delete that, and so it's not pinned to that edge, so it moved over. Now I'm going to add these 4 buttons. Remember I said I'm going to put 4 buttons on the side, so I'm just going to copy and paste one of the existing buttons. In fact, I'll paste it 4 times. I'm going to select all of them. I'm going to go down here to our embed, okay, and make a stack view out of it. I'm going to go inspect that stack view, give it some spacing. I don't want it to be leading, I want it to be fill, right? And I want to fill equally. I want all the buttons to be the same height. All right, let's go ahead and make sure that we wire it up to our card buttons array. So let's do that. Control drag. There's 1, and there's 2, and there's 3. Let's move this up a little bit. Sorry, and there's 4. Okay, so we've got it in our card buttons. Now I want these 4 to join the party. Okay, I want them to join in here, so I'm going to select both of these stack views, and I'm going to embed them in a stack view. Okay, we'll go ahead and put some spacing in there so we can see it a little better. Here I don't want them aligned on the bottom, I want them to fill. However, I do not want fill equally. Do you see why I don't want fill equally? That would make this one stack view the same width as this whole big stack view. So that wouldn't be really wide, and those would be small. But I do want this stack view to be the same width as all of these. So how am I going to do that? Okay, well, I'm going to control drag from this stack view to one of these buttons over here and say, please make them equal widths. And that's perfectly legal to do that, to have one view and just say, please always be constrained. These are all constraints. Constrain yourself to be the same width as this one over here. Okay, and that's going to ensure that even as this gets wider, that row will always be the same width as all the other rows in here. Okay, so I've created this new stack view right here. This stack view has no constraints, right? If we look over here, right, there are no constraints on it because I just created it. And so I really want it to zoom out to be constrained to the edges here. What I really want is I want it to constrain to the top of here and to all the safe areas on the other 3 edges. So I'm going to try the pin again. Remember this pin over here? So I'm just going to try putting an 8-point pin, and it's going to do that to nearest neighbor. I'm hoping it's going to pick the right nearest neighbor all on all sides. Let's see what it does. Well, maybe that worked. It's close. Let's look. It picked the top space to super view. Uh-oh, I don't want that. I wanted this safe area there. Then trailing to safe area, yeah. Leading to safe area, yeah. Bottom to the flip count. woo, this thing did pretty well. But of course, this super view thing is wrong. So let's remind ourselves how we fix that. We go to our document outline. Let's find it. It's right here, stack view top to the top of the view plus 8. And remember, we don't want that to the super view. We want it here to the safe area. Okay? So now we've got this set back up. Now, the problem here is we have all 24 buttons showing right here. See all 24 buttons? That's no good. So I don't want these 4 buttons showing in landscape. So how do I do that? I'm just going to pick this stack view, and I'm going to make it disappear in landscape. But not in landscape. It's going to disappear when I'm in a compact vertical size class, okay, which is only iPhones in landscape, turns out. Okay, so how do we do that? Well, if we inspect this stack view, I'm just going to the normal attributes inspector over here. Look at all these little plus signs. You see these plus signs? Here, plus, 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 and one down here, plus. These are all attributes of the selected thing that can be varied by size class. Okay? So it's not just whether it's hidden or not, which is what I want right here. You see, it is hidden right here. That's got a plus. But also things like the background color, or for the stack view, even the alignment, the distribution. You can have this change when you go to a different size class. It's pretty darn cool. So we're going to do a simple one, which is hidden. And the way you vary is you just press the plus. And when you press the plus, it says, oh, you want to vary hidden based on a size class. Well, what size class would you like to vary for? Well, in my case, it's compact height. I don't care about the width, so I'm going to set width to any. Any width is fine. But height, compact, yes. I want a compact variation. This gamut, by the way, you can vary based on the color capabilities of the device you're on. We're not doing that. It's not really an auto layout thing per se, but it still can be varied. And so I'm going to hit add variation. And watch what happens right over here when I hit add variation. See, we've got a new hidden. We have this hidden and another hidden. This one is HC, which stands for height compact. And right now, it's not hidden in height compact, but if I turn this on, woohoo! See, it hid that entire stack view because I'm in compact height right now. And if I go back over here to my portrait mode, you can see that it's not hidden. It's still there. See, 4 across, 5 down, it's still there. But now I want this one to be hidden. So I'm going to click on this stack view, select the whole stack view here, if I can. Can I get that? No, it's hard to. Let me zoom in a little. Okay. Selecting this whole stack view. And here I'm going to do the same thing. I'm in portrait mode right here. I'm going to add another variance. This is a variance for any width and regular height. Okay. And in that case, this one is hidden. Okay. So voila, look at that. 4 wide, 5 high, and over here, 5 wide and 4 high. Okay, let's see if this works. This is not quite going to work, but it's going to be close. All right, so here we go. Let's go sports. Look at that, 5 wide and 4 high. Excellent. Let's pick some things here like this. Okay, now let's rotate. Whoop. Okay, looking good. Let's pick something down here and rotate. Ooh, oopsie. What happened to those? See that? They're gone. I picked 2 that were in this row that got hidden. So it makes perfect sense. When we went over, they got hidden. So how am I going to fix that? Well, this is kind of a clunky UI because we're using these outlet collections to gather all these cards. But one trick I could do really easily is go back to my code here for the concentration ViewController, and just everywhere that I'm doing card buttons, looking at the card buttons, instead of looking at all 24 card buttons, I'm only going to look at the 20 that are visible at any given time. So I'm going to create a little private var here called visible card buttons. It's going to be an array of UI buttons also. In fact, it's even going to be implicitly unwrapped. And it's going to be computed. I'm just going to return my card buttons if they've been set, and I'm going to filter them by the button's super view being visible. Because if the button super view is visible, then it's visible, right? So I'm going to say not $0.superview is hidden. Okay? So these are the visible card buttons. This is a little fragile to do this, but we know that all our buttons are in stack views, so this is okay. You probably could find a much better way to calculate whether it's actually on screen or not. But anyway, and I'm just going to now replace everywhere that I use card buttons with visible card buttons. So here and here and here, I'm just finding and replacing here, paste. Okay? So now, that's going to fix this problem, I hope. Let's find out. All right, it's worked again. All right, let's go down here. These are the ones in danger. Let's try. Oh, no. How could this not have worked? Okay, that code was infallible. Well, here's the problem here. When I switch back and forth, all those views get relayed out, right? Layout subviews happens, but nothing ever causes them to get reset up from my model. So they've all still got the buttons from what they were before. So what I need to do is every time I relay out my subviews like this, I need to update my view from a model. Well, guess who comes to the rescue here? It's ViewController lifecycle, right? View did layout subviews. In view did layout subviews, I'm just going to update my view from my model. Okay, we got sports. Now we have these down here. Oops, it's the other way around, so we go this way. Okay, looks worked. We'll go, now we can get these offending ones, and they're there. Now they're in random places because we're using this outlet collection, but at least it's working. Okay, now what about the problem of where's our flips number? Okay, there's no flips there. Okay, it got pushed down below the tab bar down there. How are we going to fix that? All right, we're going to fix that in a different way, just to show you there are other ways to do these things. What we're going to do is we're going to move this flips thing up here. Now, you could imagine, let's create another one and then do is hidden on the two of them. And yeah, we could do that, but that kind of starts to get ridiculous because now I'm going to have to have another outlet to that other one. What a pain. I really just want to move this. Well, what makes this be here? What makes it be here is these constraints on it. The fact that it's aligned to the center, that it's hooked to the bottom, that the top space is hooked to that stack view. That's what makes this be here. So if I could change those constraints, I could make it be over here. And as long as those constraints only happen in height compact, woohoo, it'll switch, right? So that's what we're going to do. Now, how do we do that? Okay, we don't have the little pluses by all our constraints. How the heck do we do that? Well, we do that with this magical button right here. You see this vary for traits? We don't even need this. In fact, we could probably have we can probably don't even need document outline here. So you can really see what's going on here. All right, so here I'm working, and if I click this Vary for Traits button right here, it'll say, okay, you're going to go into a mode where all the constraints that you're doing are only applicable to the thing you're in. Okay, so let's do it. Ready? Vary for Traits. It says, do you want to vary by width or height or both? Here, it's the height that matters to me. And whoa, look at that bar. Okay, it got dark blue. So that dark blue is warning you, whoa, dude, you are editing constraints only in compact height. And in fact, it's only showing me compact height devices right here. Okay, so that blue warning is a warning. Make sure you pay attention to that. All right, so how do I get flips to move? Well, I got to take all the things that are constraining flips to be here and get rid of them. So I'm just going to go over here and delete all of these constraints. And if I go over to my document outline here and I look at my constraints, you'll see that they didn't actually get deleted. See how they're grayed out? Why didn't they get deleted? Because I only deleted them for this size class. They still exist in the other size class. Okay, so that's why they're only grayed out here when I'm looking in this one. But it is good. It freed up flips. You see, flips is no longer tied to anything. And also, by the way, of course, this little constraint right here, if I can click on it, this little I-beam right here, that's got to go as well, because that is no longer going to be constrained to the edge. It's going to be constrained to the edge of this flips thing. Right? This is going to be constrained to here. So let's go ahead and use control drag to put this thing centered vertically. Let's also use control drag to hook it up to the trailing space, although I don't want it to be 11.667. We'll do our standard 8 right there. And then let's go ahead and have this guy, we'll use the pin menu for him, and have his right edge there be to the nearest neighbor, which happens to be flips. And then also we'll use pin again to hook this bottom of this right here to also be 8 from its nearest neighbor, which is the bottom. Now all these constraints that I just put in are all only for height compact. Okay, but now I'm done varying with that. Now if I go back, you'll see, look, it had no effect over here. Okay, flips is still at the bottom, And over here, it's at the side. So let's go ahead and run. Okay, so let's first of all, let's go make sure that it's still working in the old way. So here's flips. Oh, working fine. It's staying there. Now let's go over and do it here. Oh, this one, oh, whoa. Look, oh, it's kind of jumping around a little bit. Why is that happening? Well, because the 14, 15, 11, those are different width. So that label is kind of changing its width. Wouldn't it be a lot cooler if instead of doing flips colon 14, if I made the flips be a multi-line? Okay, remember the multi-line stuff we did before? And instead of having flips colon 0, what if I did flips return 0? This makes more space, and also this 0 could be 100 and it still wouldn't be jiggling around in width. Well, that's actually really cool. Unfortunately, I just edited that, and it's also going to be true over here, and I don't want it over here. So how am I going to have something that is going to be different in these two size classes that's driven by the code? Because it's the code that decides what these things are. Well, we can do that in code as well. Let's just jump over here real quick. Here's where we do this flip. I'm just going to say trait collection dot vertical size class equals dot compact. Then I'm going to do one thing, or if it's regular, then I'll do this old thing. And the thing I'm going to do in compact is I'm going to have carriage return instead of colon. And I was going to run this, and then we would see that this doesn't quite work. But we're time constrained. I can hear 1,000 people outside the door. So I'm going to tell you one other thing, which is that this would not, if we had gone there, it wouldn't work. Okay, when we switch back and forth, it would not switch. That's because when we switch back and forth, we need to get notified that our trait collection changed. And there's a ViewController lifecycle method, which I didn't mention last time because you didn't know about traits, but now I'm going to tell you. It's called trait collection did change. Okay. And this gets called every time your trait collection changes, right? Every time your size class changes. So here I'm just going to update my flip count label. Because my flip count label, if you look at its code, it depends on the trait collection. So of course, every time it changes, I need to update it, right? Okay, so here we go. We'll go sports again. And see, this is working nicely over here. It's not jumping around anymore because it's underneath. And now let's go look here. And we got our colon. Woo, look at that. And we'll go back here. Okay, that is it. We finished before the crowds came in and trampled us. And I will see you on Monday. Your homework, remember, is due on Monday, before lecture on Monday. And hopefully you'll have a new homework going out on Monday, or maybe next Wednesday. Let's see what happens over the weekend.
For more, please visit us at stanford.edu.